Hey everybody, this is Brian and welcome to the 107th Qt tutorial with C++ and GUI programming. So we're just going to go File, New. We're going to select a Qt console application. And let's just call this 107. Actually, let's call it Qt 107. I need to get better with my naming convention here. Just put it wherever you normally put it. Alright, and we get this beautiful console application. So let's build it, and sure enough, there it is. Ta-da! So, what are we going to be talking about today? We're going to be talking about memory management with Qt. Now, I shouldn't say with Qt, I should say with C++ in general, because, well, the ugly side of C++ is that you do have to manage your own memory. Now, that can be good and that can be bad. We're going to discuss a little bit of both today. So, first thing we're going to do is include Qdebug. That way we can see what's going on here. And we're going to just say int. We're going to make a function that returns a pointer to an integer. And we're just going to say int I equal new int. And we're going to say 22. Just because I like the number 22. Don't ask me why, I just like it. Of course, we're going to return I. And down here, we're going to consume that function. We're going to say int z. Oops, sorry, int pointer to z. And we're going to say this equals test. Now let's actually just throw out some Qdebugs here. And we want to say I. Actually, we want to say, and of course Qdebug. You can tell it's been a while since I've done one of these. Wow, I can't type. I've got a whole new system. I mean, not just a new keyboard. I mean a whole new computer, new headset, new mic, new speakers. I think the only thing that really still exists was the monitor. So let's run this and see what happens here. And sure enough, we get 22 and 22. Because in test we're doing a Qdebug 22, and in the main we're doing the same thing. So if we remove the star out of that, let's just take that one out. You can see the actual address and memory of where that pointer is. Remember, a pointer, in case you slept through this part of your C++ class, a pointer simply points to a location in memory. You have what's called the heap. Now, the heap is memory. Just think of it like a big heap of hay. You just throw whatever you want on it. The more memory they have, the more places you can hide things. So when you're making a pointer to a new int, you're actually saying go out into the heap and allocate a chunk of memory. Now that chunk of memory is going to stay out there. So what's wrong with this program? I mean, it worked, but what's wrong with it? Well, we never deleted it. We've created these things out in the heap, but we never got rid of them. So then we got to go, all right, well, let's, geez, we should delete it here, right? Let's delete I. Well, I can't do that because we have to return it. So, wow, we can't do that either. So, all right, well, let's delete it here. That would tentatively solve the problem, but what if you've got a program that has hundreds upon hundreds, if not thousands of functions across multiple modules? How are you going to track when that actually needs to be deleted? What if you introduce threads into this? Oh my, yeah, you can see the complexity just goes through the roof. So what we're going to do here is we're going to talk about my friend and your friend, the QScopedPointer. Now, what is QScopedPointer? It is a automatic pointer, meaning it deletes itself. And you can see how from that tooltip it says dynamically allocated object that deletes it upon destruction, meaning it knows the scope of that pointer and it'll destroy it as needed. So let's actually, we're just going to comment that out, and we're going to do the QScopedPointer way. QScopedPointer int, we're going to say I, new int, and we're going to say 23 just so we know it's different. Then we're going to say QDebug. Now we can't just say I, because then we're just QDebugging the QScope pointer. We have to actually do the data here. So the data is actually the pointer inside of the QScope pointer object. Now we're going to return this. And let's actually comment these out. And we are going to say I want to kind of show you here. Let's just copy this guy. Ooh. Now you see the problem here. Can't convert QScope pointer int to int I in return. So what we can do is actually return the data. But you notice how, that didn't work out well. What do we do here? What we need to do is call take. What take does is it says, okay, we're going to take control over this QScope pointer. So it'll no longer be encapsulated, and it's going to pass the actual value of that over. Well, we still run the risk right here of having that memory leak. We haven't actually deleted it. You can see how there's the address, there's the data. That 23 is coming from this QDebugZ. So it's still out in memory. So we need to take care of that. So what we can do here is actually fumble around with this a little bit. I love copy and paste. I am the copy and paste king. Ta-da! See if we add that in. Now we got the 23. So let's actually recompile this one more time. Sure enough, 23. Now, when we close it, the memory is deleted automatically. Why? Because it's encapsulated in the QScope pointer. Now, you may be asking, why are you doing this twice? Why don't you just, do this right here and then return it and then handle it down here? Well, that's the thing. If you ever do any error handling, you would want to do a try catch, which we've talked about error handling before. And you're going to want to know that when that fails, it's going to go out of scope, so it'll automatically delete the memory. So even if it fails, it has an error, it's going to delete it because it goes out of scope. That's the magic of the QScoped pointer. Well, this is Brian. I hope you found this educational and entertaining, and stay tuned. I hope to make many more of these videos in the future.